When representing relations, we must first clarify what a relation is. A relation is a set, or a list, and in this set we have ordered pairs. These ordered pairs relate x values to y values. And once again, this is a set of ordered pairs. We can also represent relations using a domain and range map. It's important to know here that the domain is referring to all of the x values, and the range refers to all of the y values. What's very important about this map is that it shows what x value goes to whichever y value. So we do arrows, showing that each x value goes to its corresponding y value. A domain is a set of all of the x values of a relation, and a range is a set of all y values of a relation. But an important thing to note here is that these values, they can't be repeated within the domain or the range. If the relation had x values 0, 1, 1, 2, and the y values we don't care about right now, the domain is only the different ones. So it would be 0, 1, and 2. The same thing goes for the y values in the range. This means you can have maps that look something like this. This looks like a jumbled mess of craziness going on everywhere, but you can see that there's always an arrow coming to or from, at least one, an item in the domain, and an item in the range. So that goes over a map. Now let's talk about tables. Tables usually have a format like this, or on its side, like this. Written within these tables are the corresponding values of x and y for relations. It's important to note here that in these tables, every x and y pair are always directly next to each other, much like how they are in the original set of ordered pairs. So this gives you a good idea of what a table looks like. Remember that a table, unlike how it is for a map, you have to have the same number on the left as you do on the right. So here we have 4 on the left and 4 on the right, 4 on the bottom, 4 on the top. It has to be the same because there has to be a corresponding y value for every x value and vice versa. Now it's time to look at graphs. For graphs, the x values for the domain are always the horizontal, and the y values for the range are vertical. If we look back to our set of ordered pairs, we can now draw them on this graph and get a good look of how they relate to each other. So a coordinate may be drawn here, and the following coordinates may be who knows where. You should always be able to go from any of these representations of relations to each other. You could always go from a graph to a set of ordered pairs, or to a map, or to a table, and all the ways through to correspond to one another. A relation, here I show as a set of ordered pairs, also has an inverse. A relation takes x values and turns them into y values, but the inverse takes y values and turns them into x values. But it has to be the corresponding ones, which you'll see here. Where we had ordered pairs for the relation x then y, now for the inverse, the ordered pair starts with the y value and goes to the x value. You're essentially just switching out where you have x's and where you have y's. So if this is a map for our relation, its inverse will look like this, where now you can see the domain has become the y values and the range has become the x values. So for our relation, the domain has x values and the range has y values, but for its inverse, the domain has the y values and the range has the x values. I've been very vague about the topics discussed here, but in the examples you should get a good idea of how to use each of these things I've discussed.